Hey everybody, Matthew Doyle from Autodesk here, and today I want to show you guys something that I think is really exciting inside of my LT. It's definitely my favorite feature to play with, and that is the new ShaderFX node-based shader creation tool. And so before we actually look at ShaderFX, let's talk a little bit about what a programmable shader is. So back in the day, before programmable shaders, graphics were basically all handled on the GPU using fixed functions. So there wasn't a whole lot of programmability you could do to create custom effects in your characters and objects in your 3D games. But pretty much all graphics cards today now allow for programmable shaders. And so what you're looking at here on my screen right now is one of those programmable shaders. And we're looking at about 1,000 lines of code here. And it's not very easy to understand code for that matter. It's written in a C-style format. And basically what this code does is allows you to do, in this case, a pretty basic shader that has normal mapping, diffuse, and rim light, and a few other things. But you can see here it's pretty complicated. It's 1,000 lines, and it takes a very competent technical artist or an engineer to write this kind of stuff. And if you're into that kind of stuff, that's awesome. And I personally have been learning to write shader code. There's a couple of languages out there: HLSL, CG from NVIDIA, as well as GLSL. And every game engine out there, modern game engine, can basically read in these shaders for creating some pretty interesting material effects on your characters. But most artists are not going to want to have to write shader code like this. They're obviously going to want to do something in a much more artist-friendly way, something more visual. But before we take a look at ShaderFX tool and talk about Maya LT's implementation of that very artist-friendly visual workflow, let's just talk just briefly about some of the core parts of a shader here. So you've got, if we go up a little bit here, we've got this shader vertex function here. This is, well, basically a shader is composed of primarily two functions, and that is the vertex shader function and the pixel shader function. So the vertex shader, basically, as its name implies, takes in the application data. That is basically a data structure that contains all of the vertices of a 3D object from whatever app it is, whether it be a game engine or say Maya. And then it takes that data, each of those vertices, and it runs this function on each and every one of those verts, transforming those verts into different spaces such as screen space or world space or whatever the case may be, and any other interesting transforms, maybe adding color to the verts, whatever. And then it spits that information out. And when it does that, that vertex data gets pushed to the pixel shader, and that's the function we're looking at now. And then the pixel shader, of course, does a whole lot of other stuff to basically, ultimately, all really a pixel shader does is calculates a final color for that given pixel. And so you can see here, very complex for the pixel shader, a lot of stuff going on here. But again, all it really does is gives us an output color, and it stores that in the pixel shader data structure, which ultimately gets passed back to the application as a surface into a surface shader, which then obviously gets drawn on the screen. So that's pretty much the core of a basic programmable shader. We're looking at one in CG, that's the NVIDIA shader language. We've got the extension of .fx here. But again, most artists aren't going to want to have to write this kind of stuff. They're going to want to do something in a more visual way, and that's where ShaderFX comes in. And I love this tool, and it's really fun to play with. So what we're looking at here is this character's fin is using a ShaderFX programmable shader that I created pretty quickly. It's pretty basic, pretty simple, but it gets a lot of things across. We've got normal mapping, and we've got some rim lighting on him, as well as some image-based lighting and so forth. And you can see here we've got some of the green light from behind him being transferred onto him as well. And it's got kind of a reflective surface, and you can see the normal mapping in the rim light as well. So it's a really nice shader effect there. What we've got, if we look over into our attribute editor, we've got basically a bunch of attributes here that I have made accessible to the artist to be able to specify the different textures such as diffuse, specular, normal map, and so forth, as well as whether they want image-based lighting or not. We can adjust the intensity, the blur amount, so it's more of a sharp reflection of image-based lighting, or it's much more blurry and diffuse. And as well, my rim light here I can turn on and off. I can change the color, intensity, and so forth. But what we're going to do is I'm going to actually show you guys how I put this together inside of ShaderFX. So we're going to start from scratch, and I'll kind of talk you through some of the cooler ways of working with ShaderFX, some of the things that you can do that are pretty interesting. And so let's just go ahead and do that real quick. So we're going to assign a new material to our guy here, and when we choose a new material inside of my LT, we'll see that right at the top is our ShaderFX shader. So we'll just click on that, and we'll just go ahead and give him a name. All right. So now we can open the actual ShaderFX node-based editing tool using this button here. All right. So inside of the editor, this is what you're going to see when you first create a new shader, and it's basically got two nodes, and we can see here it's a visual system, so we can drag these nodes around simply by clicking on them and dragging them. This arrow here, we can select it, we can delete it, and so forth. Now you notice here this color is red. That means that the shader is broken. At least that particular node at that spot is broken, so we can just reconnect our surface shader here. So this guy here, this is the traditional game surface shader. This is basically the primary node that we're going to use to connect all of our properties into, such as ambient, diffuse, specular, normal, image-based lighting, and so forth. But it is going to spit all of this out after it does some stuff internally. It's going to spit all of that out as a surface shader to our final material. Now if you select the material and then go over to the attribute panel and scroll down a little bit, at the very bottom you're going to see a drop down where you can choose which shader language you want to use. So there's, you know, HLSL 3 or 5, GLSL, and CGFX, the NVIDIA shaders. And once you do that, you just give it a name and choose the location where you want to save it, and it will spit out the final shader code just like we looked at previously, and you're done. You're good to go. You can use that in your game engine. Now obviously it depends on the engine. Like Unity, for instance, uses its own shader lab system, and so it's not a perfect system where you can just take this and go straight into Unity and it works. So there's going to be a little work required on your part, but you know, if you're into that kind of stuff, you know, you'll be able to figure it out pretty easily. All right, so back to the ShaderFX window. If you right click, you'll be able to choose different nodes that you want to add to your shader network. So under hardware shader nodes, we've got a bunch of nodes here that we can add, such as flow control nodes, inputs, lighting, math, add, multiply, divide, subtract, invert, etc. Matrices, so we can do different projections. Different transforms such as view space, world space, and whatnot. Here's all our basic textures like normal mapping and diffuse and so forth. We can even do things like flip books, where you take a PNG texture that has basically a bunch of images together and create an animated sequence. Basic values like floating point numbers and booleans and so forth. Now there are actually a lot more nodes available than this. And you can only get to them though once by toggling the advanced mode. So you'll want to toggle advanced mode, and then we go back in here and we'll see quite a few more nodes are available. And this can be daunting and overwhelming at first, so you might want to stick to non-advanced mode at first, but eventually you're going to want to start playing with a lot of these other nodes. They can come in really handy to do some pretty interesting effects. Alright, so let's just start out really simple and create our basic network here of diffuse, specular, and normal map. So all we need to do is right click, go to our hardware shader nodes, and we'll just add a new texture. And in this case we're going to go with texture map right there, and we're going to wire this guy in by just clicking and dragging into our diffuse color. Alright, and so now we just need to choose our texture, and to do that we'll have to go over to the attribute panel. And we can see here where it says my texture path. We'll just need to go to our texture directory. Inside of my project here I have my textures, and we'll go with this guy right here. And so now we can see in the viewport that has updated. So we now have our diffuse texture. Now another cool thing is if you look at the swatches here, if I were to basically there's a little circular pattern here with a green dot in it. If I click on that once, it's going to make that image bigger, so you can get a better view of that texture. Now you can do the same thing on the surface shader. So if we click that once, twice, we can get the actual surface shader output. And in this case, so in the texture map, it's flat. It's the flat diffuse texture. But on the surface shader, we can see the actual specularity being played out on it. But before we go any further, let's actually take a look at the internals of some of these. You'll notice here that this surface shader has a group indicator. So with advanced mode toggled, you're going to see this little rectangular box. If it's not toggled, we'll toggle it off. That's not going to be there. So you're not going to be able to look at the internals. So if you want to see the internals of a node, you'll have to turn on the advanced mode. And then we can just click on that to go inside. And we can see, there's a lot more stuff going on here inside of the game surface shader. And we can see all the connections being made from input. So these are the inputs from the left side of the surface shader that we connect in. And then these are the outputs on the right side. And by the way, ShaderFX uses the same basic navigation as my LT does. So you've got your Alt middle click to pan, Alt right to zoom. And obviously there's no orbit, but there you go. So that's your output to the surface shader. And really all this is just someone took the time to put all this together using all of these nodes that you'll find in here. There's nothing magic in here. There's nothing special that you can't get access to through the hardware shader node list. So that's all this really is. It's just a grouping that someone has created on the Autodesk team here to basically create this surface shader as a time saver for you guys. So you can obviously create your own surface shaders doing something similar. And if you want to get out of this group, you just click the exit group and you're back to the one above that. Another thing you might want to take notice of is that a lot of these connections here are color coded. So this is, I believe the blue connections here are for floating point values with they're float threes basically. So you can have it's basically a vector of 3 values. So color would be, basically RGB. And so you want to keep that in mind when you're connecting things. You want to make sure the colors match, just like color here to diffuse color. They both are light blue. So we'll go ahead and add another texture this time. We're going to add a normal map. And we'll go ahead and connect that to, well, let's go ahead and actually choose our texture first. So back to the attribute panel. And we've got our normal map here. And we'll go ahead and connect it in to the normal input of our surface shader. And we can see the normal map applied there. If I break it again, you can see it go away. So let's go ahead and connect it again. Once again, I can make the normal map bigger. I can also, for a normal map, when I've selected it here, if I scroll down in the attribute panel, I can see I can change my normal map from tangent space to object space or world space or whatever the case may be. But this normal map was created as a tangent space normal map, so we'll keep it at that default setting. You also notice on the left side of these textures here, we've got inputs. So we've got an input for UVs, as well as in this case a normal height input. The UVs, we can specify the UV space very simply by going to our hardware shader nodes and then going to inputs, inputs common, and then UV set, and then we can just wire that in there. Now this is going to be automatically, this defaults to UV set 0, and but we don't really need it because this texture map, if we go into it, you'll notice that it actually has the UV set 0 already set up as a default using this AFB empty node. So we don't really need to specify a UV set. They're already done for us. But if we wanted to specify a different UV set, we could do that. We could wire it from the outside, and then this this condition here would test to find out if it had an alternate UV set specified, and if so, it would use that one instead. But you don't need to if you just want to use the normal UV set 0. Alright, now if I wanted to make my normals higher here, I could, using that normal height, I could go ahead and use a value here. So we'll do a floating point value and just wire that in to our normal height. And now I can go over to my attribute editor and change that value, and you can see the difference here in my normal mapping is much more stark. So we'll just drop that back to 1 and I'll just leave that connected. Let's go ahead and add our specularity now. So we'll add another texture. And we'll find our spec map there. And we'll just wire that into our specular color. Alright, so now he's a little less harsh. Now I could also specify the specular power as we can use a value there. So I'm just going to use a floating point value. I could also use a color, but I'm just going to go ahead and use a floating point value. And we can change that to something else. And we can see the difference in the viewport as I make those changes. Alright. So that's pretty basic. Just diffuse, normal, and spec. Nothing special there. But before we go any further and do something really interesting, before we add a rim light, I want to show you one other cool thing about ShaderFX. And if you've played with Maya recently, you know that we've shipped it with DirectX 11 Uber Shader. That is basically a kind of an all the bells and whistles that DirectX 11 can do in a single shader. You can do things like subsurface scattering using translucency, dynamic tessellation, normal maps, emissive, all of that great stuff, and it's all in a single shader. And the cool thing is we inside of the Maya LT directory, you'll actually find that shader file, and we can load it into ShaderFX. So I'm just going to close this guy down for a bit, and let's create a new ShaderFX shader. So let's go to the Material tab, and here we have our ShaderFX material. I'll go ahead and create it. And this time, instead of creating all of our nodes from scratch, I'm going to go to the File menu, Import Graph, and then we'll browse to our Maya LT installation. And then go to the Presets folder, ShaderFX, Scenes. And inside the Scenes folder, you're going to just find these two files here. The one we're looking for is Uber Shader Graph. And so we'll just load that up, and presto, just like that, we have that Uber Shader inside of ShaderFX. And now we can actually go about modifying all the properties that the Uber Shader normally has in the attribute panel when you add it. So obviously we've got our diffuse, specular, reflection, normal, object thickness, that's for translucency, and so forth, image-based lighting, you name it, all of it is in here. So that's really sweet. That's a little thing that I found the other day when playing around. So definitely check that out. That's going to be in the Maya LT installation under Presets, ShaderFX, and you'll be able to load in the Uber Shader. Alright, so let's jump back to our Sven character here and finish up with his shader. So let's go ahead and add a rim light now to our character, and we can see some more of the interesting effects that can be achieved. So rim light's a little more complex, but not too bad, so don't be too scared. First of all, I'm just going to grab all of these guys here and just kind of pull them out of the way, so we've got a nice blank space here to work with. And the first thing I need is my rim light, so we'll go ahead and right click and look for my rim light, which should be under lighting. There we go. Alright, so if we look at the rim light node here, we can see we've got inputs for albedo color, light vector, unnormalized, that's what the UN means, normal, Fresnel, and Fresnel color tint. So Fresnel is basically a material effect that basically changes the way a material looks based on the angle of incidence. That's the angle that the camera or eye is looking at the object, and really good for doing things like rim lights. So what we're going to do is we're going to use this node and wire it into our ambient color in this case. Ultimately, we're going to take that color output and wire it right there into ambient. Okay, so first thing we're going to do is we're going to set up our color, and to use our color in this case, our albedo color, we're actually going to just use the diffuse texture color. So next, for our rim light to work, we need to know where our lights are in the scene, where the lighting is coming from. So for our light vector, we'll add it from inputs inputs common. You can see the light vector here, and we will take the light vector, the unnormalized one, and wire that in to our rim light. Now our light vector needs to know needs a list of lights, and so we'll do that. We'll create a light list, and that we found under lighting. And this light list is basically just an array that specifies all the lights in the scene. So we'll just wire it in right there to our light index. Now, another thing that is helpful when you're building these nodes is to take note of these gray circles here next to each node. Now, if you left click on one of the gray circles, it's going to give you a list of the inputs. So in case those input names are too long, you can always get it from the list here. Likewise, on the right side here, we've got the output name. Also, if you click on the colored connections, the inputs and outputs, left click, it'll tell you exactly what type of input it expects. So in this case, we've got float 3, and in this case, we've got a normal float. Here we expect an integer. Alright, so we've got our light list ready, but we don't actually have our lights tied into it. So we're going to need to do that. So let's create some actual lights. So we'll just go to lighting, and there's my first light, and I'll go ahead and wire it into my list. You'll notice the 0 there. That means light index 0. That means the 0th light in the scene. In the case of my LT, that will be the first light that you've created. In the case of your game application, that will obviously depend on how you created your lights as well. So I'm going to add 2 more lights. There we go, light number 1. And finally light number 2, which is the 3rd light in my scene. Alright, now one interesting thing here is if you click on each of these lights, you can go over to the attribute panel. You'll notice it says lights auto. That's the default setting. It's going to automatically figure out which lights that you wanted it to use. However, if you click on the drop down, you can specify the lights. So I could choose, spotlight shape 1 and point light. And those are my 2 lights in the scene currently. Obviously, I'm going to need to add a 3rd light if I want to take advantage of this 3rd light. But for now, we're going to go ahead and move on and add the rest of our rim light effect. So now we're going to add to our rim light the actual Fresnel node. So we'll just go to Hardware Shader Nodes again. And under Lighting, you'll find Fresnel. And of course, we'll wire in that Fresnel multiplier output to our Fresnel input on the rim light. And already we can see now that our shader is starting to show our rim lighting Fresnel effect there, using the lights that we specified. So our Fresnel effect has several inputs here. We're going to need to, if we really want an interesting rim light that actually takes into effect the normal map of the character, we're going to need to wire that in here. But this is not a required input here. We could just leave the Fresnel as is, but I like to use the normal map as well. So we'll go ahead and go down to our normal map. Let's just drag that Fresnel down there for a second and bring it right in. Alright, so next we need our camera vector, because again the Fresnel effect depends on the angle of the camera from the object. So we'll go to our hardware shader nodes and inputs common and choose camera vector. In this case we want a normalized vector. And finally we have inputs for min, max, and strength that will control the Fresnel effect, and all of these are going to be float values. So we'll just bring in our min, and the max, and finally the strength. Now when you've got a bunch of these things together, it can get kind of unwieldy, wondering what all these vowels and stuff are for, these values. So if we go ahead and select the node and go into our attribute editor where it says name here, you'll see val. We can just change that to say rim light, in this case min, right? And so now that says that here inside of ShaderFX, it's much more easy to understand what this connection is, what this node is. We'll do the same thing here, rim light max, and finally rim light strength. Now another thing you're going to want to do is when you don't want necessarily a regular artist, a texture artist, to be mucking around in here once you've built your shader. If you're a tech artist, obviously, so you might want to basically just expose a lot of this to the artist in the attribute editor, and that can be done simply by selecting a node and then putting a checkbox check mark in this input from Maya. So we can see that when you do that, this little sample preview window here turns into the Maya logo, and that means that when you close the ShaderFX window, so we'll just go ahead and do that now, those values are still accessible from the attribute editor. So we don't have to open this up to make changes there. Alright, so let's continue on here. We're almost done with our rim light effect. I'm going to pull these guys out of the way some more. I just want to add a color tint to my rim light here. So we're just going to go ahead and add a new value. Color. Simple as that. And we'll wire in the RGB to the Fresnel color tint. Let's move this out of the way so we can see. So right now our color is gray, so let's just go to the attribute editor here. We can change it to something a little more interesting. Alright, and obviously we're not seeing much of our Fresnel effect here, so we're going to make some adjustments to the values. There we go. So you can see the effects that it's having there. And of course our strength value, we can bring it way down, we can punch it way up, but obviously we want to keep something. Always go for subtle when you're working with graphics, and people tend to go for really strong effects, really bright, really colorful, or saturated images, but always go for the subtle stuff. That's the more realistic looking. Unless of course you're doing something cartoony or very stylized. Alright, so that's our rim light. And again, we can go through here and expose a lot of these things to the attribute editor. We've already got the min, max, and strength exposed, but we might want to actually expose the lights. We want to allow the artist to be able to choose which lights or whatever the case may be. But we also might want to make it so the artist can toggle the rim lighting on or off. And that's pretty easily done using a conditional statement of flow control. So if we go into our flow control here and find a basic if-else, so if-else basic, and just add that in here. We can also then create a Boolean value. Alright, and then we'll just go ahead and wire this Boolean value's output to our condition input. And let's call this Boolean value rim lighting. And we'll do an input from Maya so they can access it from the editor instead of in here from the attribute editor. And what we want to do is we want to say, if this Boolean is true, we're going to output whatever's connected to the true input. And if it's false, we'll do whatever's connected to the false input. Now the great thing is we don't have to wire something to the false. We could just leave it blank. In that case, we don't do anything. So what we're going to do is we're going to then wire this result to the ambient here. But before we do that, we're going to need to connect our rim light to the true. So we'll just delete that connection, wire this to our true, and then wire the output, which now receives the same data type, which is a float 3, to the ambient color of our character. So I'm just going to close down ShaderFX, and you'll notice here as I toggle rim lighting on and off, it's using that conditional statement to decide if we're going to use our rim lighting. So very effective, very cool. What I'm going to do though is take it back to the original shader that I had applied to my guy here. So I want to show you a couple other just really quick things, and then we'll wrap up the video here. But if I load up the original shader, so looking at my attribute panel here, I have this shield effect in my shader. If I turn that on, we can see an example of an animated shader effect by pressing the play button on our time slider here. So we can see we've got this kind of cool panning gradient ramp going across his body, creating a sort of kind of futuristic shielding effect. And rather than show you how that's built, I'm going to provide my shader graph in my blog post so that you can download it and have a look at it. But just briefly, it's actually quite simple looking at the shader here, this is all I have at the top is my UV panner node. There's my gradient ramp texture. You'll notice that it's kind of animating there in the preview there. Of course, if you go to settings and turn on play animated shaders, you'll be able to do that. And then we've got a clamp operation that gives us our min and max inputs, and then we're just adding that into our rim light in this case, and then passing that to our ambient. So anyway, check out the shader graph on the blog if you want to see more about that. You'll also be able to see how a basic image-based lighting setup is done down at the bottom here. And so that's going to do it for now. So again, really cool new feature. I have a lot of fun myself playing with it. I'm sure you guys will too.